Right now, literally as we speak, there is a colossal mystery hanging over our heads, and humanity is about to launch a revolutionary new machine to finally solve it. Welcome back to another explainer. Today, we are unpacking the Nancy Grace Roman Space Telescope. This is the next great eye in the sky, and it is going to fundamentally break and then rebuild our understanding of the cosmos. It's going to be a wild ride.
Okay, let's dive into this, because this fact always blows my mind. Every single thing you have ever interacted with, every star, every galaxy, the planet we're standing on, it all makes up just 5% of the universe. 5%. The other 95%, it is completely invisible. We're talking about a vast expanse of dark matter that binds galaxies together, and dark energy that's literally driving them apart. We absolutely know it's out there, but right now, it's basically a ghost to our current instruments.
So that brings us to this monumental question. How do you actually map the invisible? I mean, how do we study something that doesn't emit light and reflects exactly zero radiation? To figure out what dark matter and dark energy actually are, we've got to look at the universe on a scale we haven't ever really attempted before. We need a completely different kind of tool for this job. Which brings us to Section 1, Meet the Roman Telescope, scheduled to launch in August 2026. Named after Nancy Grace Roman, who is famously known as the mother of Hubble, this brand new observatory is going to sit about 1.5 million kilometers away from Earth at what's called the L2 orbit point. And to really grasp why it's such a game changer, you have to compare it to Hubble. So they both share a 2.4-meter primary mirror, right? But while Hubble peers super deeply into tiny, narrow little patches of space, kind of like looking at the night sky through a drinking straw, Roman is built for these massive, sweeping, wide-angle views. So the crucial point is, Roman actually has a field of view that is 100 times larger than Hubble's. 100 times. And the craziest part is it does this without sacrificing a single pixel of pristine image quality. It's basically trading that drinking straw for a giant Ultra HD bay window. It's going to capture these huge expanses of the cosmos in a single shot that would literally take Hubble weeks or even months to stitch together. Now, because of that massive field of view, Roman is going to be an absolute data fire hose. Over its 5-year primary mission, it's expected to gather up to 20 petabytes of data. To put that sheer scale into perspective, that is the equivalent of 10 million high-definition movies. 10 million! We're going to have an unprecedented, sprawling map of the cosmos literally right at our fingertips. Moving right along to Section 2, Hunting for Alien Worlds. You see, Roman isn't just going to look at the dark universe. It's also set to be a historic hunter of cold, long-period exoplanets hanging out on the freezing outer edges of their star systems. By staring straight toward the center of our galaxy, it'll monitor hundreds of millions of stars simultaneously for something called microlensing. Basically, when a closer star drifts in front of a background star, its gravity acts like a natural magnifying glass. And if a planet happens to be orbiting that closer star, it creates this tiny telltale spike in brightness. That little signature alone could reveal over 2,000 completely new worlds. Now, what's really interesting about this slide is how Roman actually takes things a step further with its coronagraph instrument. This is a tech demonstrator designed to directly image these worlds. Check out this process. As blazing starlight enters the instrument, Roman generates an opposite light wave. Through destructive interference, these waves literally cancel each other out. It basically erases the blinding star and reveals the faint little glow of the planets orbiting it. It is an absolutely incredible piece of tech that's paving the way for us to find habitable rocky worlds in the future. All right, into Section 3, Decoding the Dark Universe. So, how is Roman finally going to address that missing 95% of the universe we were talking about earlier? Well, using that massively wide field of view, it's going to map the cosmos on a macro scale. First, to map dark matter, it will measure weak gravitational lensing. These are just tiny, almost imperceptible distortions in the light from distant galaxies, caused by invisible clumps of dark matter warping space. And second, to understand dark energy, Roman's going to track the distribution and the acceleration of massive galaxy clusters, hunting for that mysterious force that's driving our universe apart. Which leads us to our final section, the ultimate cosmic network. The thing is, Roman isn't going up there to work completely alone. It is actually the missing piece in a vast cosmic network. Take a look at the incredible synergy between Roman out in space and the ground-based Vera C. Rubin Observatory down in Chile. While Roman perfectly surveys the near-infrared spectrum from space, completely free from atmospheric distortion, by the way,
Rubin handles the optical sky from the ground with its massive 8.4-meter mirror. Their survey footprints are intentionally designed to overlap and totally complement each other.
And speaking of data fire hoses like we did earlier, Rubin is equipped with the world's largest digital camera. We are talking about a staggering 3,200 megapixel sensor. In just a single 30-second exposure, it captures an area of the sky 40 times larger than the full moon. Rubin is currently undertaking the legacy survey of space and time. This is effectively creating the ultimate ultra-high-definition 10-year time-lapse of the southern sky, catching millions of cosmic changes, like supernovae and moving asteroids, literally every single night.
And this brilliantly illustrates the wide and deep dynamic we also have with the James Webb Space Telescope. Roman is the ultimate target finder. It sweeps these vast areas to identify the most extreme or weirdly anomalous objects, and then it hands those exact coordinates over to JWST. Webb then acts as the deep probe, right? It uses its massive mirror and that SPF 1 million sunshield to zoom way in to analyze those specific targets, peering up to 13.5 billion years back in time. Basically, Roman finds a needle in the haystack, and Webb examines the needle. But this multi-messenger network stretches way across the solar system, and even beyond. We've got the Europa Clipper heading to Jupiter's moon, the asteroid-hunting OSIRIS-REx, Mars legacy orbiters like MAVEN, and even Nanograph, which detects background gravitational waves using dead stars. Roman is joining what is essentially an unstoppable fleet of off-world detectors.
Let's move to and see how this builds over time. Just look at the rapid technological leaps in our astronomical infrastructure over the last decade. We've gone from MAVEN arriving at Mars in 2014 to Webb launching in 2021, Rubin seeing first light in 2025, and this all culminates in Roman's upcoming 2026 launch. Step by step, we are literally turning the entire solar system into one synchronized, highly sensitive observatory. How cool is that? I absolutely love this quote from Dr. Scott Ransom regarding the Nanograph pulsar network because it hits the nail on the head for everything we've talked about today. He said, as we keep listening, we'll likely be able to pick out notes from the instruments playing in this cosmic orchestra. Roman, Rubin, Webb, all the planetary probes, they are all just different ways to listen to this grand cosmic symphony. Each one is picking up different frequencies and movements that we just couldn't hear on our own. In 2026, the Nancy Grace Roman Space Telescope is finally going to turn the lights on in the dark rooms of our universe. It's going to map the invisible, find thousands of hidden worlds, and harmonize with the greatest machines humanity has ever built. So I'll leave you with this provocative thought. When Roman finally opens its incredibly wide eyes, which hidden note of our universe will it uncover first? Thank you so much for joining me on this explainer, and as always, keep looking up.